In this case, we are dealing with a strong and concentrated base, which has a concentration of 9.74 times 10 to the minus 1 mole per cubic decimeter, and we want to find out what the pH is. So first of all, we know it is a base, and therefore we must assume that the pH will be larger than 7, because that's the definition of a base, that the pH is larger than 7. Now, we cannot directly calculate the pH in this case because we are dealing with a base. But what we can do is we can try to figure out first the pOH, then we calculate the pH from this one. So what is going on? Let's write down a sort of a scheme so that we understand what's going on. Let's say we've got our base, and I denote this here with a minus. An iron, for example, plus water, and the base will basically grab one of these protons and will be turned into the conjugate acid, and it leaves an OH minus group, a hydroxy group, behind. Now, that would be the scheme, and you noticed I wrote this with this very uneven equilibrium, which basically means that almost all of the base that I have at the beginning, almost all of it will be converted into the conjugated acid. Or in other words, if I have, for example, 1 mole of the base, I will, at the beginning, I will also get then 1 mole of the conjugated acid and 1 mole of the hydroxide ions. And that is what we are going to use in this case, because what we can do is we can calculate the pOH of a solution, and we know that the definition of the pOH of the solution is minus log to the base of 10 of the hydroxide ion concentration, and I write it like that. That is the hydroxide ion concentration in the solution. And because we know that the hydroxide ion concentration in the solution is approximately the concentration of the base, and I probably should indicate here that this means the base. So the hydroxide ion concentration is approximately the concentration of the acid, because it is such a strong acid. We can substitute this hydroxide concentration by log 10 of the base concentration that we have. Now we can calculate the pOH. We just simply need to put in the concentration minus log 10, and we had the concentration of 9.74 times 10 to the minus 1. And we need to be careful here, because we know that in the definition here for the pOH, this needs to be either in mole per cubic decimeter or mole per liter, which is also often abbreviated as mole. But we've got it already in the correct unit, so we just simply can put this into a calculator, and we would get a pOH value of 0.011 roughly. Now we've got a pOH value, but we really want to have the pH value. So how can we do that? Well, we use our knowledge of the relationship between pH and pOH, because we know that pH plus pOH, at least in water, adds up to 14. Now we can very easily calculate the pH. So the pH equals 14 minus pOH, which we've just calculated. So that's 14 minus 0.011. And for the pH, we therefore would get 14 minus 0.011. That gives us 13.898. And we see that the pH is definitely larger than 7, so we can be quite confident that we are on the right track here. So this is how you can calculate the pH of a strong concentrated base. I hope this makes sense, and thank you very much for watching. That gives us 13.989. Is that right? Yes, that is correct, 13.981. And what we see is that this pH value certainly is larger than 7, which we postulated up here, so we can be reasonably confident that this is correct. So this is how you calculate the pH value of a strong and concentrated base. I hope this makes sense, and thank you very much for watching.